Hey Kara, I'm going to do this math problem for you. The goal of Common Core is not just to screw up math, you guys. The goal is actually to make sure that everybody in every state is learning the same things at every grade, because how it was before, if you moved from like Oregon to Maine in 3rd grade, you probably missed something. Or you moved to Maine and they were doing things that you did last year, or they had already, moved ahead and you missed some. So we had a lot of children in our country who had holes in their language or in their math because they missed something by moving. So the goal of Common Core is just to get everybody on the same page at the same time doing the same stuff. So all the 3rd graders in our country learn the same things at the same time. It wasn't just to make math harder. This is the math problem that we're talking about today. The old way, like everybody knows, 2 into 15, well, 2 goes into 15 7 times, and you divide, multiply, subtract, and bring down, and then you 2 is 9 is 18, 0, right? 79. This is great if you want the right answer. But this is just a series of rules. I know that 2 times 7 is 14. I know that 2 times 9 is 18 because I know that. But I don't know why. There's no relationship. There's no number language there. And what this math method, not Common Core, I mean, this is a part of Common Core, but that's not all that Common Core is. But this math method is trying to teach me a relationship with numbers so that I can intuitively think with numbers, because numbers are a language. Just like English or French, you can think in numbers. So what I'm going to do here is, because I'm a kid and I only know my multiplication facts up to 10, I know that 158 is a really big number. And I've got to get 2's into that. So the biggest thing I know, 2 times 10 is 20, right? So I'm going to put a 10 up here. It doesn't really matter where in this method. And I'm going to subtract 20. Well, that leaves me with 138. So now I've got to keep counting up to get to having no remainder here. So if I were doing this on a classroom with a bunch of kids, I would ask them to give me a number. And I would say, give me a number. And they would say, oh, 9. Okay, 2 times 9 is 18. Now that's handy dandy. That's a great way, because when I do this, I end up with 120, right? Which is a nice round number. And I've gotten rid of that pesky 8 over there. Yeah, okay? So if I were in a group of kids and I said, hey, give me another one, we're going to go by 2's, they'll see this and they'll see that 12 and they'll say 6. All right, let's do a 6. Well, that didn't work how we thought it would, because it didn't really get rid of the 12 over here, got rid of the 12 over here, and we're left with 108. Well, let's do another one. We want to get rid of the 8. Let's do a 4. 2 times 4 is 8. I've got 100. So now I'm going to do just a bunch of 10's, because I'm a kid and I'm wanting to go quick. So that subtracts a 20, which leaves 80. And do another 10, and that subtracts another 20, which leaves 60. And another 10, which subtracts a 20, and leaves 40. And another 10, which leaves 20. I'm going to go over here. I'm at 20. And then one more 10 will get rid of that final 20, and I'm at 0. That's where all those weird numbers came from. The 10 and the 10 and the 10 and the 4 and the 6 and whatever. When I add these up, I'm going to get 79. 10, 20, 30, 40, 50, 60, 9, 79. It's the same answer. But what this is, and why this is handy dandy and good for us, is because when I was reading these messages on Facebook a minute ago, I was at Home Depot buying an air conditioner. The air conditioner was $185. And I didn't just hand the lady at Home Depot $185. I counted up 20, 40, 60, 80, 100, 120, 140, 160, 180, and 5. That's how we do money. And that's how we do change. And that's how we do a lot of things intuitively in math. So that's why this is useful. It's because it's giving me this relationship between all these numbers, and it's how we count money in our culture. It's not just to be a pain. I hope that helps.